So the next section is about solving absolute value inequalities. So I have abbreviated absolute value just with abs for absolute and val for value. I hope that's okay. So solving an absolute value inequality is going to be pretty similar to solving an absolute value equation, but there are a couple modifications to the procedure that we need to make, although it's going to be very similar still. So the first step is still the same. We want to isolate the absolute value part on one side of our equation. And the second step is still going to be kind of the same. We're going to split that absolute value inequality into two linear inequalities. I put a little star next to there because the way we do that splitting is a little bit different. There's like one little extra thing we have to worry about there. But it's still kind of the same basic second step. The third step is still the same. We're going to solve each of those two linear, in this case, inequalities separately. The fourth step is different, though. So we're not going to be checking absolute value inequalities. What we're going to do is graph the two solutions on the number line. And we're going to do that to determine whether we have an AND inequality or an OR inequality. And I'll talk more about what that means and how we do that in a moment, but that's the gist of things. So again, procedure quite similar to what we've already done in the previous section, right? Not exactly the same, but a lot of it is still the same. Let's do some examples to get kind of acquainted with this. So solve for x. Do some examples here. Excuse me. So the first step is to isolate the absolute value part. So in this case, I'm going to subtract 1 from both sides. At this point, I've isolated the absolute value, so I can split this into two inequalities. The first inequality is going to be the exact same thing, just without the absolute value symbol. The second inequality is going to be the exact same thing, except I need to negate the right-hand side. And I also have to flip the inequality. So when we do that negating of the right side, we also need to remember to flip the inequality. That's the little bit, or the part that's a little bit different, because we have that little bit extra thing to worry about. But that's not too bad, right? Okay. So now I'll just solve each of these two inequalities separately. So I'll subtract 3 from both sides to do that. So I have x is greater than 0 for one, and then x is less than 6 for the other. Negative 6, excuse me. And to determine now the last step, what I'm going to do is draw my number line. So if I'm going to graph x is greater than 0, I start by making a mark at 0. Should the mark at 0 be a filled-in circle or an open circle? Open. Why will it be open? Because my inequality is a strictly greater than. It's not a greater than or equal to. And then I'll draw an arrow. Which way should my arrow be pointing? To the left or to the right? To the right, because I have x is greater than 0. The things that are greater than 0, the numbers like 1, 2, 3, 4, those are to the right of 0 on the number line. Now I'll do the same thing for x is less than negative 6. So I'll start by making a mark at negative 6. The mark I make at negative 6 should be open circle. And then I'm going to draw an arrow. Which way should my arrow be pointing? To the left. Remember, this says x is less than negative 6, so the things that are less than negative 6 would be like negative 7, negative 8, negative 9. Those lie on to the left on the number line. Okay. So the open circle means that that value is not included. So if I was talking about the things that are less than negative 6 is not less than negative 6. So that's why we're using an open circle there. Okay? So notice here, bless you, where these arrows are pointing in opposite directions from each other, they're pointing away from one another. That situation is the OR situation. So I'll say my final answer is x is greater than 0 or x is less than negative 6. If you don't write the OR there, I would mark that down. Okay? But it's easy to tell if it's an OR. All we have to do is plot them on the number line. And that's not so bad. Let's do another. Let's say we have the absolute value of x plus 4 minus 10 is less than or equal to negative 2. First thing I should do is add that 10 over. And then we'll break this up into two inequalities. What should the first inequality be? Good, the same thing without the absolute value. What should the second inequality be? Yeah, so I'm going to have x plus 4 is greater than or equal to negative 8. Everybody okay there? All right. To solve this, we'll subtract 4 from each side. That's going to give me x is less than 4, and it's going to give me x is greater than negative 12. So let's plot this on the number line. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4. A lot of tick marks. All right. Let's do x is less than less than or equal to 4 first. My mark at 4, open or closed? Closed, because it's or equal to. And then should the arrow be going left or right? Left. Because less than 4 are things like 3, 2, 1. Those are to the left of the 4. X is greater than or equal to negative 12. The mark I make at negative 12 should be closed. The arrow should be going left or right? Right. So the things that are greater than 12 are things like negative 11, negative 10, negative 9. Those are to the right. See how the two arrows are pointing towards each other? That's the and situation. So, question. Correct. Is it possible to get something like this, where they're both pointing the same direction? Not for us. This likely indicates that you've made a mistake. The most likely place to make the mistake is forgetting to flip that inequality when you make your second equation. I would say the majority of the time that students end up with an answer where the arrow's pointing in the same direction, it's because they forgot to flip that inequality. So if that happens to you and you get an answer where both the arrows are pointing in the same direction, that's the first place to look, is to double check and make sure that you did flip that inequality. Let's do one more example of this. Time. Of course. All right, so -2 times the absolute value of 3 minus x plus 8 less than or equal to 6. First thing I would want to do is subtract the 8. Very good. Okay. Next thing I should do is divide by -2. What do I have to remember here? Why did I flip the inequality symbol? When you multiply or divide both sides of an inequality by a negative number, you have to remember to flip the inequality. So this has nothing to do with the making the two equations part. This is because I multiplied or divided by a negative number. Can you add or subtract a negative number from both sides and not flip? Yes. It's only for multiplication and division that we need to worry about that, but you absolutely need to worry about that. Everybody okay there? Okay. We'll make my two inequalities then. The first one, nothing changes. The second one, the right-hand side negates, and again, I have to flip that inequality. Okay. So to solve, I'll subtract 3 from both sides. And then we'll have to divide by -1. What are we going to have to remember to do in this case? Flip those inequalities. Just more it's like we're Simone Biles here, just doing flips all over the place. That's a gymnastics joke. Right, she's that little tiny gymnastics girl. No? Okay. Fine, whatever, I get it. Don't laugh at any of my jokes. So, x is less than or equal to 2, so I have my filled-in circle at 2. Oh my gosh, look at what happened here. And flip it. Jeepers creepers. And then less than 2 is that. Filled-in circle at 4. Greater than 4 is like that, so this is the or situation. So hopefully that feels pretty okay. It's basically the same thing as last time, right? We have a little bit of modifications for dealing with the inequality part, but overall it's not terribly different. I do want to do a little bit more about solving, though, because there's a situation that we that can happen that we haven't addressed yet. So I'm going to just do a little bit more on solving. So this is, again, we're talking about solving equations now and not inequalities, so we're kind of backtracking a little bit to ideas from yesterday, or, sorry, we didn't meet yesterday, from last time. I just need to get in the habit of just saying last time, because I can't keep track when these classes meet anymore with the schedule. So again, first thing I want to do is to isolate the absolute value. Oh! I've done that. There's nothing to do, right? We've already have the absolute value by itself. I guess let's pause here before we get going too far into this. How is this fundamentally different than the problems that you'd seen in last time's homework? I have x is inside my absolute value and x is outside my absolute value, right? So this is a little bit different kind of problem than we've seen in the homework last time. So, just like the usual, I'll break this into two equations, making sure to negate the right-hand side of the second equation. To solve then for x, I'm going to subtract 2x from both sides. So I have 12 is equal to 2x. And 12 is equal to negative 6x. Divide both sides by 2 and divide both sides by negative 6. And I get x equals 6 and x equals negative 2. So nothing strange has happened yet, right? If I go to check now, 2 times 6 plus 12 equals 4 times 6. 2 times 12 is 12. 12 plus 12 is 24. The absolute value of 24 is 24, and 4 times 6 is also 24, so that answer worked. If I try the negative 2 now, 2 times negative 2 is negative 4. Negative 4 plus 12 is 8. The absolute value of 8 is 8. 4 times negative 2 is negative 8. Those are not the same. So this one fails to work, and I end up with just one answer. We hadn't seen a situation like this happen in yesterday's homework where we got two answers, but only one of them worked out on the check. Right? You saw getting one answer, but it was because when we split and made the two equations, they were both the same equation. We hadn't seen this situation happen where when we do the check, only one of them worked. Right? So that can happen. For it to happen, though, we need to have a situation like this where we have x's inside and outside the absolute value. Will it always happen in this situation? No. You can still have no solution or two solutions. Let's do one more example. To just kind of reiterate the idea here. So we have the absolute value of 4x minus 1 equals 2x plus 9. Again, the first step would be to isolate the absolute value, but look at that, it's already isolated. So I can go straight to step 2, right? So we'll split this into two separate equations. Now when I negate the right-hand side, notice the right-hand side contains two parts. So when I'm negating the right-hand side, I really need to think about it this way, where I'm distributing that negative. So I need to negate all the pieces on the right-hand side, not just the first piece. I want to really emphasize this here because this is a place that I would say the majority of the students make mistakes. Even once we've pointed this out and done examples involving this, comes to test time or something, and this is a place where students make a mistake, they forget to distribute that negative across everything on the right-hand side. Oftentimes it'll just be the first thing on the right-hand side that gets negated and they forget about everything else. So please kind of take note of this situation. Be on the lookout for this situation. It's going to happen in the homework. I guarantee you'll see one on the test that this will happen. So please try not to make that mistake. Again, as you'll notice that when we do these example problems, I really try to emphasize like places where students make mistakes frequently and point those out so that you can be aware of them. So the students that think, oh, I won't do that, are exactly the students that do that. So just kind of like take the advice. It's good advice. All right, to solve for x now, I'm going to subtract 2x from both sides. That got the 2x out of there. And I'm going to add 1 to both sides. That's going to get the 1 out of there. So I have 2x is equal to 10. Similarly, I'm going to add 2x to both sides here, and then add 1 to both sides there. That gets rid of the 2x and the 1. That gives me 6x equals negative 8. So if I divide both sides by 2, I get 5. And if I divide both sides by 6, I get negative 8/6, which reduces to negative 4/3. If I check these, they both work. I hope you'll take my word for that. I think at this point we've done enough checking to where you guys should feel comfortable doing that. And they should work out. Okay.